My dear students, now I am taking second part of 10th class chapter 5th, relation and functions. So in first part we have studied the Cartesian product of two sets, and now in second part we will take a relation. I will define relation. A relation is a recognizable connection or link between two objects and quantities. My dear students, you know, in a ordered pair, there are two elements. If these two elements, or you can say these two objects, have some relation each other, then this ordered pair belongs to R. You can say it will be a element of R. This is the definition. A relation is a recognizable connection or link between two objects and quantities. Let A and B are objects and have a relation each other. Then AB belongs to R. If there is no relation between A and B, then this AB does not belong to R. Understand my point? So, in other way, you can say a relation from a set A to B is a subset of product A into B, because when you find out the Cartesian product of two sets, then the subset of that Cartesian product, yes, that is the subset of A into B is a relation, is subset will be a relation if subject to the condition that in any ordered pair, if both the elements have some relation, then it will be a element of relation, otherwise not. This is the definition. So I am taking it with the help of example. The concept will be more clear to you. If AB belongs to R, if AB belongs to R, it means A is related. A is related to B. Understand? If AB does not belongs to R, it means A is not related to B. Not related to B. So I think the concept is clear to you. Which pair is a member of relation, which pair is a element of relation, is or not. So now I will define relation. With the help of example. Let A is equal to 1, 2 and B is equal to 3, 4, and find out the Cartesian product A into B. 1, 3, 1, 4. Take 1, make the pair with 3 and 4. Now take 2, make the pair with 3 and 4. This is the Cartesian product of this. Here you see that 1, 3, first pair, first 1 3 belongs to R because 1 and 3 both are odd number, and related to each other, This is so. Second pair, take second pair. We have to check one by one. 1 4. In this 1 4, this is odd number, this is even number, does not belong to R. Right here, both have no relation. You have to write here, both have no relation. Third, 2 3. 2 is odd number, even number, and 3 is odd number. This also does not belong to R. And you have to write here because 2 and 3 both have no relation each other. 4. 2 4. Both are even number. And belongs to R. Here write, both are even numbers. And have relations. And have relation each other. So, and in two cases, here you have to write no relation. So, my dear student, now this relation, how will you write this relation? R such that A tends to B is equal to 1 3 and 2 4. Only these two ordered pairs are members of this relation, are elements of this relation, and these two ordered pairs are not not the element of this R. This is the relation. I think it is clear to you. Now, this is the relation. Now, I will take empty relation. For example, here you see, first, I am taking this example. I'm not going to write another example. Here, you have to understood with the help of this example. What I am saying, listen very carefully. 1 3 does not belongs to R. Suppose these two elements have no relation. Second, 1 4 does not belongs to R. Both these elements have no relation. Third, 2 3 does not belongs to R. Also 2 3 have no relation. Fourth, pair 2 4. Also these two elements have no relation each other. No relation each other. No relation with each other. Here also, and here also. It means a relation R such that A tends to B is equal to phi. You can write it as, because in this relation there is no ordered pair which belong to this relation, and there is no element of this relation. So therefore this relation is empty relation, and it can be denoted as phi. This is empty relation. You can write empty relation. empty relation. Now, with the help of this example, I will explain universal relation. Universal. Empty relation, universal relation second. Now, with the help of this example, I will try to make you understand that AB is equal to this, and here we will write it again. 1 3 belongs to R because both have relation. Both have relation each other. Understand this point. Both have relation each other. This also belongs to R because both have relation each other. This pair is also belongs to R because both have relation each other. This pair is also belong to R because both have relation each other. It means all the elements of this product, all the elements of this product, or you can say all the ordered pair of this product belongs to R. It means this whole product goes to the relation. So therefore this is a universal relation, and you can write it R such that A tends to B is equal to 1 3 1 4 1 3 1 4 2 3 and 2 4. This is a universal relation. With the help of this only one example, I have tried to make you understand what is the relation, what is the empty relation, and what is the universal relation. These terms I have defined fully with the help of this example. Not only definition, this is the third, and second was the empty relation, and first was the relation, I have explained with these only this example these three relations. I think the concept is very clear to you because there is no difficulty in understanding these definitions. The examples are very simple and understandable. Now, I am taking some question. I am taking a question. A relation R. Example first. Now, these were the definitions. Now I am taking question. Example first. What R such that A tends to A. This is a relation, and this relation is defined as xy. This is a question of book. Y is equal to x plus 1. This is a relation, and we have to write, and we have to make this relation in with the help of diagram, and we have to find out all the concept belongs to this relation, such as domain, range, codomain, whether it is a relation or not. We have to see all these things with the help of this example. Now, make the relation R. If x is equal to 1, then y is equal to 2. Now put here x is equal to 2. y is equal to 3. X is equal to 3, y is equal to 4. Put here x is equal to 4, y is equal to 5. And put here x is equal to 5 and y is equal to 6. And so on. Now, you can take more, one pair, 6, and that is 7. Now, this is the diagram A. This is also A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, 1 with 2. The image of 1 is 2. Image of 2 is 3. Image of 3 is 4. Image 4 is 5. And image 5 is 6. Now, this is the relation. This is the relation from A to A. In this relation, 1, 2, 3, 4, 5 have images in A, 2, 3, 4, 5, 6. Or in other words, you can say 2, 3, 4, 5, 6 are pre-images of 1, 2, 3, 4, 5. Element of A has a image in B or in A, and this element of second can have pre-image in first. So this is a relation. And now domain. Domain is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In the domain, we have to take all the elements which have images in second set. Range. Take those elements which have pre-images in first. That is 2, 3, 4, 5, and 6. These elements have images in second, and these elements of second have pre-images in first. So this is the domain and this is the range. And codomain, very interesting topic. Codomain, all the elements of A, 1, 2, 3, 4, 5, 6. Here there is no question of images and pre-images. In codomain, you have to take all the elements of the second set. This is the first set, this is the second set. So this is a relation, and I defined this relation with the help of this diagram, arrow diagram. And the domain, range, and codomains are according to the images and pre-images. Now I am taking second example. I think you are taking interest in relation. Example 2. This is a very good topic. Relation and function must be very clear to you, so that the next chapters will be very easy for you. So, second question. A relation R such that A tends to B such that XY, what type of relation is XY, such that X is A, X is the square, X is the square, X is the square of Y, X is the square of Y. This is the condition. According to this condition, first of all we will make a diagram. Here 4, 9, 25. Here 1, 2, 3, 1, 2, 3, and -1, -2, -3, -4, -5. 1, 2, 3, 4, and 5. I write these numbers in positive in upper side and negative downside. And images of 4 is 2 and -2 also. This is yani relation, write the relation 4, 2 and 4 -2. Now 9 have images 3 and -3. 9, 3, 9 -3, and 25 have images 5 and images -5. 9, 25, 5 and 25 -5. This is the relation. Because these are the, and others numbers are extra numbers. And numbers of A and elements of A 4, 9, 5 and elements of B are all these numbers according to the condition. So this is the relation according to this situation. Now domain, I have told you all the numbers in set A 4, 9, 25. These numbers have images in set B. So this is the domain. And range, all those numbers which have pre-images in A, that is -2, +2, -3, +3, -5 and +5. These numbers have pre-images in A. These numbers have images in B. These numbers have pre-images in A. So this is the domain and this is the range, and codomain is all the numbers of this 1, 2, -2, 3, -3, 4, -5, +5 and others, and 1 and others. This is the codomain. Those numbers which are according to this condition, you have to write in B, and that will be the codomain of this relation. Codomain of the relation A to B. Now, this is the second question. And you have seen that this relation is very important topic, and everything is clear to with the help of these examples. So in the last, my dear students, I will take third part tomorrow, that is function. And I want to make a request to you, please subscribe the channel. I shall be very thankful to you. Thanks.